Today I'm here to talk about geometric distributions. In the previous set of notes, we looked at the binomial distributions. Geometric distributions are very similar, where there's 4 properties that must be met. 3 of the 4 are the same. It's the 4th property that makes geometric distributions different. Here are the properties of a geometric setting. Similar to binomial settings, we have success or failure. One of 2 things must occur. The probability for success is the same for every observation. Observations are independent. That means one outcome does not influence the probability of the next outcome. And here's where they're different. The 4th property. I'm now interested in continuing over and over until I see my first success. In a binomial setting, I have a set amount of trials. In a geometric setting, I'm just going to keep going until I get my first success. For example, I could flip a coin until I get a heads. If I flipped tails, 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 and then finally get a heads, it's what's the probability of getting that first heads on the nth trial. Rolling a die until I see a 2. I'm going to keep rolling it, and once I get success being a 2, I'm going to stop rolling. Shoot baskets until you finally make one. I could miss several times in a row. In a geometric setting, I would be interested in making my first shot, let's say on the 5th trial. In a binomial setting, I would have a set amount of 5 shots, and I could ask the question, what is the probability that I make 3 out of those 5 shots? Here, I'm just going to keep shooting until I finally make one. Let's look at rolling a die until you get a 6. Here's the 4 properties, and you can see how each property holds for the geometric distribution. Success would be rolling a 6. Failure is anything else. My probability is the same, 1/6. Each roll is independent, and option 4 is the one that's different. I'm going to keep rolling until I finally get a 6. Here's your formula for calculating geometric probabilities. Probability of x being n, where n is the nth trial. P is your probability of success. Let's see how this holds true on the probability of rolling a 6 on your first roll. We should know that the answer is 1/6. There's 6 things that can happen. The probability of rolling a 6 should be 1 out of 6. So let's follow the formula and make sure it lines up. The probability of your success happens on the first roll, x equals 1. 1 minus the probability of success, 1 minus 1/6, raised to the n minus 1, times the probability of success. 1 minus 1 is 0. Anything raised to 0 is 1. 1 times 1/6 is 1/6. Now these probabilities should decrease as n increases, because eventually I'm going to roll a 6. So let's make the probability distribution. X can take on the values that success could be. The first trial, the second trial, the third, the fourth, and this can go on infinitely. Here's the probability of success on any of those trials. Now I just used the formula, interchanging the x values to come up with this. But there's actually a faster way. If you put the probability of success on your calculator, in this case 1/6, and hit enter. Then type in the probability of failure, in this case 5/6. If I hit enter here, this will give me the probability my first success occurs on the second trial, 0.138. If I hit enter again, that would give me the probability of success on the third trial, 0.115. And then I could just simply continue hitting enter for each x value. Essentially what I'm doing here is the probability of success on the third trial would mean that I failed twice and then I had success. So I fail, fail, succeed. 5/6 times 5/6 times 1/6. If I made a graph of the histogram, it's obviously going to be skewed to the right because my numbers are getting, for probability, are getting smaller and smaller as I go along. If you would prefer to use the calculator in similar fashion to a binomial setting, you can do that with the following calculator command. You can always use the formula. This just might save you a little bit of time. The operation is to hit second, distribution, selecting geometric PDF is to be option D on some calculators. And then the calculator is going to prompt you to type in two numbers. The first number is going to be the probability of success. The second number is going to be N, where the success happens on which trial. Hit enter and it will calculate your probability for you. You can make a histogram using the following setup as you see on the screen. So let me take a second to show you how that works on the calculator. If the question were, what's the probability that you roll your first 6 on the third roll? I hit second, I hit distribution, I scroll down to geometric PDF, hit enter. The probability of success is 1/6, and I said the probability of rolling your first 6 occurs on the third roll. Close the parentheses, hit enter, and you can see the same probability, 11.5% chance of not getting your first 6 until the third roll, same as the chart. In similar fashion, I could pose the question, what's the probability that I see my first success within 3 rolls? So I could have success on the first roll, the second roll, or the third roll. I can find these individual probabilities using a geometric PDF and then simply adding them up. Or if you saw on the calculator, I have the option of selecting a geometric CDF, meaning a cumulative distribution function. Here the calculator will add the probability of success on the first plus the second and the third. So if I wanted to answer that question, probability of success happening within 3 rolls, not on the third roll, hit enter, and you can see this value is higher. It's the summation of the first 3 probabilities on the probability distribution. Which can be seen here. 0.166 plus 0.138 plus 0.115 will equal 0.4212. So the probability of success on the third roll, exactly 11.5%. The probability of success within 3 rolls, 42%. Here's your formula for the mean of a geometric random variable. This is also considered the expected value. The mean mu is 1 over p. So on the average, what's the probability, on the average, how many rolls until I see success when rolling a die? 1 over 1/6 is 6. The law of large numbers says, in the long run, every 6 rolls I should get success. And then I have another formula at the bottom here, the probability that it takes more than n trials to see your first success. 1 minus p raised to the n. Here's an example problem just to make sure you know what's going on. Take a basketball player, knowing that she makes 80% of her free throws, and put her on the line. I'm going to let x be the number of shots until she misses. My question to you is, what's the probability that she will make at 5 shots before she misses? I'll give you a moment to try to work this out. At this point, you'd probably want to hit pause and then hit resume when you think you're ready for an answer. So here's your answer. She makes 80%, that means she misses 20%. What's unique about this problem is that success is actually missing a shot. If you read the question, what's the probability the player will make 5 shots before she misses? So missing is the success, meaning the miss happens on the 6th shot. So in purple, following the formula, probability of failure raised to the n minus 1 times probability of success, 0.8 to the 5th times 0.2, 0.0655. You can also do this on the calculator. You would follow a geometric probability distribution, typing in 0.2 for the probability, comma, then 6, hitting enter, 0.0655. And that's pretty much it for geometric distributions. Keep in mind, the only difference here is we're going to keep going until we see success versus a binomial distribution. We have a set amount. Now, when I separate these two topics and do a bunch of problems on just geometric, it's pretty simple. The tricky part on the AP exam is they're not going to tell you whether it's geometric or binomial. You're going to be asked the question, and you need to figure it out. The deciding factor between binomial or geometric. Set them out, or you keep going. Keep those two things straight. You know where the calculator commands are. Should be pretty simple. See ya.